In this tutorial, we will be discussing Charles's law, which discusses the relationship between temperature and volume. As the temperature increases, the particles are moving faster and faster and faster. And when that happens, they spread out. When that happens, the volume then increases. So as the heat increases, the particles move faster, hitting the walls harder and forcing the container to spread out. This brings us to this equation here. V1 over T1 is equal to V2 over T2. The easiest way to go about this is just simply cross multiply and divide. Make sure that your units are matching up. So in other words, they're both in liters or they're both in milliliters. Also, make sure that your temperature always is in Kelvin. So if I look here, a balloon has a volume of 785 milliliters. I'm okay with it being in milliliters. It doesn't have to be in liters. It just tells me that the new volume is going to be in milliliters as well. So 785 milliliters at 21 degrees Celsius. That word at links the volume and the temperature together on the same side of the equation. But I notice that this is in degrees Celsius. Before I do anything else, I want to convert that over to kelvins. So that's 21 degrees Celsius plus 273. That comes out to be 294 Kelvin. If the temperature drops to 0 degrees Celsius, so 0 degrees Celsius, once again, that's in Celsius, I have to do something about that. 0 plus 273 is equal to 273. What is the new volume of the balloon? So that's V1 over T1 is equal to V2 over T2. So the V1 is 785 milliliters. The T1 is 294 Kelvin. That is equal to V2, which is what I'm looking for, and T2 of 273 kelvins. Once you get this far, the easiest thing to do is just simply cross multiply and divide. So we're going to cross multiply these. 785 times 273. That comes out to be 214,305 is equal to 294x. If we wanted to look at the units here, this would be milliliters times kelvins, and this would be kelvins. I'm going to divide both sides by 294 kelvins. And this is why, as long as your units match up, you're okay. With the exception of temperature. Temperature 100% of the time has to be in Kelvin. These cancel. The kelvins cancel. So it's 214,000 divided by 305. $214,305 divided by 294. That comes out to be 729, and we're left over with milliliters. Let's try one last one. A sample of oxygen gas has a volume of 420 milliliters. That's going to be our volume. There's that at word again. That means 420 is going to be linked to this 18 degrees Celsius. Once again, I see 18 degrees Celsius. So that means I need to change the degrees Celsius over to Kelvin. So 18 plus 273. That comes out to be 291 Kelvin. At what temperature in degrees Celsius, notice that they're asking for it in degrees Celsius, will the volume of the oxygen be at 640 milliliters? That's going to be our V2. So V1 over T1 is 420 milliliters over 291 Kelvin is equal to 640 milliliters over X. So 640 times 291 come out to be 186,240. Once again, those units are going to be milliliters dot kelvins is equal to 420 milliliters times X. So I want to get X by itself, so I'm going to divide both sides by 420 milliliters. The 420 milliliters cancel out. The milliliters cancel out. That leaves us with kelvins. So 186,240 divided by 420 come out to be 443 kelvins. However, it's asking for Celsius. So I need to subtract 273 to get it back into Celsius. And that is 170 degrees Celsius. If you decide to take a shortcut and leave it in 18 degrees Celsius, you will get it wrong. You don't want to do that. Make sure you always convert it to kelvins and then convert it back. And that is Charles's law.